Welcome to The Explainer. Today, we're going to dive into a few classic physics experiments, and we're going to use them to uncover three fundamental and, honestly, pretty surprising secrets about light. So yeah, let's just get right into it.
You've seen this before, right? A simple little prism splits a beam of white light into a gorgeous rainbow. It feels familiar, kind of magical even. But what you're seeing is actually the first clue in a way deeper mystery. It's telling us that light isn't just one thing. It's a bunch of different things, all traveling together. And believes me, that is just the beginning.
Okay, so our first secret is hiding right there, inside that rainbow. See, the whole reason a prism even works is because light bends. It's a phenomenon called refraction, and it is the very first key to unlocking how light really works.
And at the heart of all this is something called the refractive index. It's basically just a number, but it reveals a pretty shocking fact. The speed of light isn't always constant. Nope, it actually slows down when it travels through different things, like water or glass. And this number, n, well, it's just a way to measure exactly how much it slows down. So why does changing speed make it change direction? Well, picture a line of soldiers marching from smooth pavement onto thick sand, but at an angle. The first soldiers to hit the sand are going to slow down first, right? And that's going to cause the entire line to kind of pivot and turn. Light waves do the exact same thing. The part of the wave that hits the glass first slows down, and that forces the whole wave to make a turn. And look, this is not just some cool trick with the prism. We have taken this bending power and used it to build our entire modern world. It's how your eyeglasses focus light so you can see. It's how fiber optic cables can trap light and send our data across oceans. And it's even how scientists can tell you how pure something is just by seeing how much it bends a little beam of light. And this effect, it changes wildly depending on what the light is passing through. In air, light barely slows down at all. But in water, it's about 33% slower. And get this, in a diamond, light slows down by a factor of almost 2.5. That's actually what gives a diamond its incredible sparkle. It bends and traps light more dramatically than almost anything else. Okay, so light bends when it changes speed. We got that. But why does it do that? Well, the answer leads us to an even deeper secret. Light isn't just a straight line, like a ray. On a much more fundamental level, it behaves like a wave. And trust me, that changes everything. For the longest time, we just thought of light as a simple ray, shooting in a straight line. But thinking of it as a wave, that reveals a much richer, way more complex reality. As a wave, light can spread out. And, most bizarrely, it can actually interfere with itself, creating brightness from nothing and darkness from pure light. The proof is, well, it's pretty mind-bending. All right, so the first piece of evidence is called diffraction. Now, if light were just a ray, and you shone it through a super tiny slit, you'd just expect a tiny spot on the wall, right? But that is not what happens. Instead, the light wave actually bends and spreads out, creeping into the area that should be a shadow. Now, take that idea and just multiply it by 1,000. When you pass light through a grating, which is basically just thousands of tiny little slits all lined up, you don't get a single spot, you get this incredible complex pattern of light and dark with different colors spreading out at different angles. A simple ray could never, ever do that. It can only happen if light is a wave. This second piece of evidence is even stranger. It's called interference. This is what happens when two light waves meet up. If their crests, the high points, line up, they get brighter. But, and this is the wild part, if a crest meets a trough, the low point, they can completely cancel each other out, creating total darkness from two beams of light. And you can literally see this with your own eyes. This pattern, called Newton's rings, is made by trapping a super thin layer of air between two pieces of glass. Light waves bounce off the top and bottom surfaces of that tiny air gap, and they interfere with each other, creating these stunning, perfect circles of bright light and total darkness. It's actually light canceling itself out. And this isn't just some weird thing you see in a lab. This exact same principle is at work in the anti-glare coating on your glasses or on a camera lens. They use a microscopically thin film that is perfectly engineered to make reflected light waves interfere with themselves and cancel each other out. That's how they get rid of glare. Pretty cool, huh? So, we've seen that light bends and that it acts like a wave. But its wave-like nature has one more secret up its sleeve, and this one is maybe the least intuitive of all. Light has a hidden property, a secret direction that proves it's a wave beyond any doubt. Just think about this for a second. We've established that light is a wave.
But a wave can vibrate in different ways, right? Is it vibrating up and down, side to side? Or is it vibrating in all directions at once? The answer is the key to our next secret: polarization.
So the light coming from the sun or from a light bulb is what we call unpolarized. Its waves are vibrating in every possible direction all at once. But we can filter it. A polarizing filter acts kind of like a picket fence. It only lets through the light waves that are vibrating in one specific direction, say up and down. This filtered, orderly light is what we call polarized light.
Now here is where it gets absolutely amazing. Certain things, like sugar dissolved in water, are optically active. And what that means is, because of their molecular shape, when you pass polarized light through them, they physically twist the light. They rotate the direction of its vibration. And we can actually measure that twist using an instrument called a polarimeter, which just uses a second filter to find the exact new angle of that light.
And this effect is incredibly precise and really, really useful. The amount of that twist is directly related to how concentrated the solution is. So people in the food industry actually use these polarimeters to check the exact sugar concentration in these massive vats of syrup, all by just measuring how much it twists a beam of light.
So we've uncovered the secrets of light. It bends, it interferes with itself, and it has this hidden direction. But the final takeaway here is that these rules, they aren't just secrets about light. The rules that govern light actually reveal something really fundamental about the fabric of the universe itself.
Take a look at this. It's a standing wave, and it's created just by vibrating a simple string. You can see parts that are shaking like crazy. Those are the antinodes. And then parts that are completely still, the nodes. Does that pattern of high energy and low energy remind you of anything?
It should, because it's the exact same principle as the interference patterns we saw with light. A wave travels down the string, it bounces back, and it interferes with itself. And under just the right conditions, a state we call resonance, it creates this stable pattern. It's the same physics, just happening in a different context.
You see, the universe basically speaks in the language of waves. It doesn't matter if we're talking about light or sound or a vibrating string, the core ideas are the same. Wavelength, frequency, interference. These are universal properties that just describe how energy moves through the cosmos. And you know what? It goes even deeper. The back and forth motion of a wave is just one example of an even broader principle: oscillation. From the simple, predictable swing of a pendulum all the way down to the vibrations of atoms themselves, the universe is just filled with these rhythmic, repeating motions. So the secrets of light end up revealing this profound truth. Our universe is built on just a few simple, elegant rules that repeat themselves everywhere we look. The same wave principles that make a rainbow also govern the sound coming from a guitar string. It really proves that the cosmos speaks in a language of vibration and rhythm. It kind of makes you wonder, what other universal secrets are just hiding in plain sight, waiting for us to ask the right questions?